You're welcome to our next video. In this particular video, we are still looking at Mathematics Primary 7. And my name is Teacher Ambrose. We are looking at perimeter of sectors. So now, in this particular subtopic, when we talk of perimeter of sectors, perimeter in actual sense is the distance, total distance around the figure. So if they say find the perimeter of any figure, you must move around that figure and add the total distance you covered. So now we're going to look at some numbers where we shall be required to find the perimeter. But in particular, we're going to look at sectors. Just to remind ourselves, sectors are parts of fractions of circles. There are very many of them. There is a semicircle like this one here. There are quadrants. There are other sectors with specific degrees. But of course, we are going to look at all of them. So in this question, number one, they say find the perimeter of the figure below. Let's use our pi to be equals to 22 out of 7 because we will be required to use it somewhere. So in this case now, they want us to find the distance around this figure, which is actually its perimeter. So if I'm to start moving from here and they want me to move around this figure, I can cover this part and then I also cover this part. So now what I will have covered will be perimeter. Now, to find the perimeter of this figure, this distance here of the arc, this curved part, it has a special name. It is called circumference of this semicircle. And then this one down is the diameter. So that means to find the perimeter of this, I must add circumference plus diameter. I will have moved around, isn't it? But now we have to ask ourselves, how do we find circumference? For those who have not watched the previous videos, you realize that in one of the lessons we looked at how we can find circumference of a semicircle. How do I find circumference of a semicircle? Since a semicircle is a half of a circle, the formula of finding circumference of a full circle is 2 pi r or pi d. But now since a semicircle is a half, that means its circumference will be equals to pi d. And a half pi d, its circumference will be equals to a half pi d. That is the formula of finding circumference of a semicircle. So that means our circumference will be equals to a half times the value of pi, which is 22 out of 7, times the diameter, which is 28 decimeters. And now, if I'm to reduce this, I'll say by 7 is 1, by 7 is 4 decimeters. By 2 is 1, by 2 is 11. So that means my circumference will be equals to 1 times 11 times 4 times 4 decimeters. Remember, we are still working on circumference, not perimeter. We are only getting the distance of the curved surface. So that means our circumference will be equals to 1 times 11 is 11. Then times the 4 decimeters. And your circumference will be equals to 44 decimeters. Now that is the distance of the curved surface. But the question is asking for perimeter, which is the total distance around this figure. So now how do I get perimeter? Now to get our perimeter, I must now say it is circumference plus its diameter. Circumference plus diameter. If I start from this point, I add circumference plus diameter to move around the figure. So that means my perimeter now will be equal to circumference, which is 44 decimeters plus the diameter, which is 28 decimeters. So that means to get our perimeter, which is the distance around this figure, is now adding 44 plus 28. And if I add 44 plus 28, I'll get 72 decimeters as the distance around the semicircle. So whenever they ask you to find perimeter of any sector, you must know which areas am I supposed to add. Like in this case, we have added circumference plus diameter to move around this figure. So this is our example number 1. We shall leave this example number 1 and also look at another kind of sector, not necessarily now a semicircle. So let's leave the semicircle and go and look at another sector. In our example number 2. So in this number, we are now going to our question number 2, which is our example number 2. Example number 2 is saying, work out the perimeter of a quadrant of radius 14 decimeters. They are saying use the value pi is 22 out of 7. So we are now running away from the semicircle in number 1. We are now looking at a quadrant in number 2. Remember, a quadrant is a quarter of a whole circle. So if I draw this quadrant, it is supposed to look like this. A quadrant which is like this. This is our quadrant, and this angle must be 90 degrees. And they are saying the radius, which is from here up to here, is 14 decimeters. And they are asking us to find the perimeter of this figure. Remember, we said perimeter is the distance around the figure. So now around this figure, to find the perimeter of this, if I'm to start from this point, I must add this distance, which is radius, plus this one, which is circumference, plus this one, which is radius. I will have moved around. But of course, do we still remember how to find circumference of a quadrant? I have said a quadrant is a quarter of a circle. And the formula of circumference of a circle is either pi d or 2 pi r. But because we have been given radius in this, that means if it was a full circle, its circumference would be 2 pi r. But now, since a quadrant, I must first get the circumference of this part of this quadrant. And circumference of a quadrant is a quarter times 2 pi r. 2 pi r is for a full circle, but because of a quadrant, you divide the 2 pi r by 4. So this is the formula of working out circumference of this quadrant, which is the distance of this curved surface, of this curved edge. So that means our circumference of the quadrant will be equals to a quarter times, which value of pi have they told us to use? 22 out of 7, times 2 times 22 out of 7, then times the radius, which is 14 decimeters. And in this case, you can even reduce. I can say by 7 is 1, by 7 is 2 decimeters. By 2 is 1 by 2 is 2. And by 2 is 1 by 2 is 1 decimeter. So that means our circumference of this quadrant will be equals to 1 times 1 times 22 times 1 decimeters. And when you multiply this, you will realize that the circumference of this quadrant is actually 22 decimeters. That is the distance of this curved part we are seeing. But we are not got the perimeter. Now, how do I get the distance around this figure? I'm now going to add circumference. If I start moving from here, I will add circumference plus this radius in order to move around the figure. So that means my perimeter equals to circumference plus radius in order to move around the figure. So that means our perimeter equals to the circumference, we already got it to be 22 decimeters. Now, plus the radius, when you look at this figure, if this is a quadrant, if this is 14, even this must be 14. So I'll now say circumference is 22 decimeters plus the 14 decimeters, then plus another 14 decimeters. Now we go ahead and add this. Our perimeter will be equals to, when I add these first two, I will say 22 times 14, you get 36 decimeters, then plus the other 14 decimeters. And your perimeter will be equals to 36 plus 14, you will get 50 decimeters. And that is the distance around a quadrant of radius 14 decimeters, as you are seeing in this drawing. So this is our question number 2. But we have one more number, which is number 3, which is now not a semicircle and not a quadrant. So let's leave this and look at our last example, which is number 3. Now this is our question number 3. They are saying find the distance around the sector below. Now this sector is not like number 1 and number 2. This is a sector where the degree is actually 60, which is 60 degrees. So this is actually just a part of a full circle. And they want us to find the distance around this figure, which is actually its perimeter. And just like we did number 1 and 2, perimeter of this figure, I will add this curved length, which is actually circumference of this sector, plus this radius plus the other radius. But what fraction of a full circle is this? To simplify your work, say this is 60 degrees, ask yourself, what fraction of a full circle is this? The full circle, the degree is 360 degrees. But if this is 60 degrees, what fraction of the circle is this? So I can reduce 60 degrees out of 360 degrees. And we see what fraction of the circle is this, where I can cross this way, that. By 6 is 1, by 6 is 6. In actual sense, this is a sixth of a full circle. That means to get this circumference, I will not say circumference equals to a sixth times 2 pi r. 2 pi r is circumference of the whole circle, but this is a sixth of the whole circle. So that means my circumference will be equals to a sixth times 2 times the value of pi. We are no longer going to use 22 out of 7 because we are being directed to use 3.14, which is the same as 314 out of 100 times the radius, which is 30 centimeters. Now from here you can go ahead and reduce. You can reduce this with that. And then you can say by 2 is 1, by 2 is 3, and by 3 is 1, by 3 is 1. So my circumference will now remain 1 times 1 times 314 times 1 centimeters, all this out of 10. That means our circumference will be equals to, when I multiply 1 times 1 is 1. Times 314 is 314. 314 times 1 centimeters, you get 314 centimeters out of 10. And that means our circumference, S decimal, is the same as 31.4 centimeters. So this is the length of this curved surface. But they are asking for the distance around, and this is radius, even this is radius. That means they are equal. So now to find our perimeter, I will now say perimeter of that sector equals to circumference plus radius plus radius. And your perimeter will be equals to, the circumference is 31.4 centimeters plus the radius, which is 30 centimeters. Then plus another radius, which is 30 centimeters. So our perimeter will be equals to, if I'm to add the other two, I will have 31.4 centimeters plus 30 plus 30, you get 60 centimeters. And your perimeter will be equals to 60 plus 31.4, you get 91.4 centimeters as the distance around this sector. So this is our last example. That's example number 3 on finding perimeter of sectors. So whenever you get numbers like this, please just follow the steps you have followed in number 1, 2, and 3, and you will get the distance around the figure easily. Of course, before leaving, I'm going to leave you with some numbers that you can try on your own and work it out. So this is our last example. So I'll now give you some few numbers. So these are the numbers I've left for you to do at your free time. there are actually three numbers. Number 3 is having part A and B. In number 1 and 2, use pi as 22 out of 7. Number 3, part A, use pi as 3.14. And then part B, use pi as 22 out of 7. You work it out and get your answers. So this is the end of our lesson. Please keep on watching other videos. Thank you so much.